Okay, we've made our instrument, we've standardized, scaled and calibrated. We're now going to run some little experiments. What you can do is you can blindfold yourself to it and get someone in the bubble in your family to make up an unknown mixture, and then you use your instrument to determine what the actual salinity of that is. What I'm going to do is I'm going to just check that standardization and calibration. You always want to check your instrument with our fresh water. We've got rainwater here, so fortunately that's fine. And just do a quick check that it's reading spot on. Bottom meniscus 1, that's it, fine, good. And now I've made up a new solution, a new C, 35 parts per thousand, and we're going to run a wee experiment. It could be a time series or it could be a transect through space. Time and space are the two variables that we could look at here. Our time series is going to be outside. It's just been raining, got a bit of autumn rain, so let's go outside and set up our experiment. Okay, here's our experiment with our time series. If we've got our seawater here and we've simulated or modelled a little pool and we've got a little bit of rain happening, we can take a series of measurements over time and investigate the effect of rainfall on the salinity of a rock pool. Let's do that. Okay, we know it's 35, made it. We're just going to leave that for a while. Maybe come back every hour, every 2 hours over the course of the day as it's raining. Right, let's get back inside. Change through time and space, fundamental for the universe. So let's now do a time series across a transect in space. Let's go down to our front yard sea and see what effect this weather is having on the fresh water from the stream meeting the seawater from the estuary. Let's take a sample and spin our little instrument, and look at that, 0. So we've still got a lot of freshwater influence, rain, drainage here, and we haven't seen yet the effect of the salinity of the tide coming in. The other thing we could ask ourselves is, how is the salinity varying across space? Let's do a wee transect down the creek here. We have already taken another sample after 2 hours and found that the salinity is now 25 parts per thousand according to our instrument. Meditating on this and gazing out the window at the rain, it raises the curious question, what has more effect? A short burst of rainfall or a period of time under intense solar radiation, which would cause the greatest change in salinity? Following the question, and proposing that a period of rainfall for 2 hours was likely to have a greater effect on salinity change than evaporation becomes a proposition. Such a proposition, based upon background knowledge, experience and observation, is called a hypothesis. And testing a hypothesis is a very large part of science as well.